This is 9.3, rewriting radical expressions. It's been a while since you guys have probably simplified square roots, so just as a reminder, like if you have the square root of two items inside A times B, that's the same thing as taking the square root of each of them. And so here's some example, like the square root of 6 is the same thing as the square root of 2 times the square root of 3. The square root of x times y, is the same thing as the square root of x times the square root of y. So let's look at this one. So if I had the square root of this big thing here, so each of them, if you literally think of it as different square roots, so the square root of 9 times the square root of 25 times the square root of x squared times the square root of y. So literally think of each one of them separately. Because a lot of students, what they'll do is they'll multiply these guys together and get some really big number and then try to take the square root of that. But think of it separately, and it's a lot easier sometimes. So the square root of 9, if we can simplify, we're going to simplify. So this is 3. The square root of 25 is 5. Now, the square root of x squared. Remember, square rooting is literally the opposite or the inverse operation of x squared. So it's kind of like adding and subtracting, multiplying and dividing. So square rooting and squaring are literally the inverse operations of one another. So this literally just goes to x. So again, think of the square root and the square, they literally kind of cancel each other out. And then you have the square root of y. He is just, he's not a perfect square root, so he just stays inside that square root symbol. So on the outside of the square root, I have 15x. And then on the inside, I have the square root of y. So 15x times the square root of y is the simplified answer to that original problem. So what we're going to do is we're going to start simplifying each one of these square roots. So we're going to start off kind of simple. I'm going to show you two different methods. Again, anytime a math teacher shows you two different methods, it's not to confuse you. It's to because we are all created differently. We all think differently. So one of some of you guys may choose the prime factorization method, and some of you may choose to think like the perfect squares method. And there's two different ways to do this. So one of the ways that is a good method is called prime factorization. So if you remember the tree method, like if you took this number and you did the tree, like 9 times 7 and 9 goes to 3, basically you break it down to all prime numbers. Break it all the way down to prime numbers. So the square root of 63 is the same thing as the square root of 3 times the square root of 3 times the square root of 7. And again, if you write each of these separately, it's like that. And I know also the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is just a plain 3. So anytime you see a pair of numbers like that, a pair of square roots, it literally is going to end up just being 3, because again, the square root of 3 times the square root of 3 is 9, and the square root of 9 is 3. So this final answer, square root of 63, is the same thing as 3 square root of 7. Now, another method of how to do this is to literally think of two square roots that multiply together that will give you 63. But one of them has to be perfect. One of them has to be perfect. So if you remember your perfect square roots, like the square root of 1, the square root of 4, the square root of 9, the square root of 16, the square root of 25, the square root of 36, those are perfect. So it just starts, and that list goes on forever, but the square root of 63 is the square root of 9 times the square root of 7. And the square root of 9 happens to be perfect, and that goes to 3, and then the square root of 7 stays inside. So notice I got the same answer, okay? But I wanted to show you two different methods. Now, I like this method, the perfect squares method, because it's quicker. If you know your perfect square roots, it actually works out very fast. But sometimes you can't think of those perfect square roots, especially on bigger numbers. So the prime factorization method is a good method to know as well. I would encourage you to know both methods. Again, the perfect square root method, I believe, is a lot faster, but the prime factorization comes in handy when you can't think of that perfect square root. So let's look at another one. Again, both methods, the prime factorization, if you broke this down to nothing but prime numbers, So that would be 2 times 2 times 11. And again, that would be the square root of 2 times the square root of 2 times the square root of 11. And anytime you see a pair, it just goes to a normal number. And the square root of 11 is still stuck inside. So again, the perfect square roots, if you think of 2 square roots that multiply together give you 44, and that would be 4 times 11. And the square root of 4 is 2. So again, I got the same answer. I'm showing you 2 different methods. Choose whichever method you feel more comfortable. But again, I would suggest you make sure you know prime factorization, because sometimes, even me, I can't think of the perfect square root right off the bat, and then I have to revert back to prime factorization. So prime factorization is a good method to learn to make sure you know the basics, just in case you can't think of that perfect square root sometimes. All right, the square root of 80, again, if you broke this down to a bunch of prime numbers, so 2, and again, all I'm doing is the tree method, so I'm dividing by 2, and that gives me 40, and then I'm dividing by 2. So a lot of us can do this in our head, so that's going to give me 40, 20, 10, and 5. All right, so, and then this literally breaks down the square root of 2 times 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 the square root of 5. And then any pair of square roots that you see go to a normal number. And so this goes to just a normal number. This guy is still stuck inside of the square root, and so 4 square root of 5 is your final answer. I just multiplied the outside numbers to give you 4. Perfect square roots, again, you think of your perfect square roots. What times what is 80, but one of them has to be perfect. Well, I would go with 16 times 5. So 16 times 5 is 80, and the square root of 16 is 4. Now, by the way, just as a side remark, a lot of students on this one, what they'll do is they'll do this, 4 times 20. And 4 is perfect, and so they'll go 2 times the square root of 20, and they'll actually leave their answer that way. Well, remember, what we're trying to do is to simplify all the way. So notice square root of 20 is not simplified all the way. So again, if you do perfect squares, make sure you come up with the biggest possible perfect square root, not just any square root. So here was, 4 is a perfect square root, but square root of 16 is a bigger perfect square root, and you want the most, or the largest perfect square root to be able to do that. Or just continue to simplify after you're done. So let's look at another one, get a little bit more complicated, more involved. So again, prime factorization, you have a 3 on the outside, but notice what's on the inside. You're going to break this down to prime numbers. Square root of 3 times the square root of 3 times the square root of 3. And you still have a 3 on the outside. So this breaks down inside the square roots, write those individually, and again, you have a 3 on the outside. Any pair of square roots that you see goes to a normal number. So this goes to a normal 3. This is just a normal 3. This guy is still stuck inside of the radical. So this would be 9 square root of 3. And again, if you're doing the perfect square roots, you're thinking of 2 square roots that multiply together give you 27, and that's 9 times 3. And the square root of 9 is a perfect square root, so that would be 3. And then again, I'm just going to multiply the outside numbers, 9 square root of 3. Again, I'm working at both methods just so you're totally familiar with both types of methods. Now, what I want to do is I want to start simplifying with variables on the inside. So again, there's several ways I can show you how to do this. But again, if you go back to prime factorization, it's a good way to do this. So 63 would be 3 times 3 times 7. If you wanted to do it this way. And then x to the 9th. Now what I want to do, notice this is an x squared, a square root. So because of that, what I'm going to do is I'm going to break x to the 9th down to x to the 2nd, x to the 2nd, x to the 2nd, and x to the 1st. Because this is a 2, I want these guys to be x squares. And you'll see why. Once I start breaking it up even to the next step, you'll see why I want to do that. So again, if you break this up individually, square root of 3 times the square root of 3 times the square root of 7 times the square root of x squared times the square root of x squared times the square root of x squared times the square root of x. So anytime you see a pair of square roots, that goes to a normal number. This guy is still stuck inside. Now remember the square root of square, they kind of cancel each other out. So that just goes to a normal x. This goes to a normal x. This goes to a normal x. This guy is still stuck inside. And this is why I want to emphasize, this is why I wanted those to be, because it's x, the square root of x squared literally cancel each other out and you're left with just x. That's why I broke this up into a bunch of x squareds. So now everything on the, you have something on the outside and you have something on the inside. So everything on the outside, let me highlight that, is those three on their outside, and then these are on the inside of square roots. So the yellow highlights would simplify to 3x cubed, and then what's on the inside would be 7x. So this is your final simplified answer from here to there. And again, there are several different ways to do this. This is one way if you want to break it down to be simplified under prime factorization. That's what you're thinking. And after you do several of these problems, you'll be able to do a lot of this in your head without showing all of these individual steps. So again, on this one, what you're going to do is break this down to square root of 5, 5, and then x squared x. Because this is a square, you want a square root, you want this to be square. And so again, if you think of this individually, square root of 5 times square root of 5 times the square root of x squared times square root of x. So individually square roots. Anytime you see a pair of square roots, that goes to a normal number. This goes to a normal x. This guy is still stuck inside. So 5x square root of x is your final answer. Again, this right here, you're going to break this down to square root of 2 times the square root of 2. Again, this right here, what you're going to end up doing, if you break this down to x squared, x squared, x squared, a bunch of these, it's got to add up to be 17. Okay, so that's what it all equals. And again, once you don't really have to do this. Once you get the hang of this a bunch of times, you'll see what's actually taking place here. And I'll go through that. So again, if you write these each individually, the square root of 2 times the square root of 2, and then each of these individually. So any pair that you see goes to a normal 2. This goes to a normal x. And again, this is just still stuck inside square root of x. So again, if you simplify all this, 1, 2, 3, 4, 5, 6, 7, 8, x to the 8th power, and then you still have the square root of x. Now something to show you how to get to a quicker way of doing this, if you notice this, what you could have done at the very beginning, a quicker way to do this, if you haven't noticed a pattern already, really, if you can basically divide this by this, and that's really what you're doing to be able to simplify this. And this literally it goes in 8 times, and so that's x to the 8th on the outside, and there's 1 remaining. That's really what we're doing. And you're dividing 17 divided by 2, and there's 18 or 8 of them, and there's 1 remaining. So that's 8 of them go outside, and then 1 remains on the inside. So that's one way to do this, especially if this was a high number like 50 something. You don't want to write all those x's out, and so it's just really a quick division to be able to get to your answer, and that makes it a lot quicker to be able to do that. And then one last thing is we want to compare and basically see if these are equal to one another. So this right here is already simplified. Sometimes you can simplify it, and sometimes you can't. So that's already simplified. Here, if we broke this down again into prime factorization or the fast way, whichever way you want to do this, the perfect square roots. So this would be 2, 2, 3, 3, 3. And so this would be the square root of 2 times the square root of 2 times the square root of 3 times the square root of 3 times the square root of 3. Any pair that you see goes to a normal number. Any pair that you see goes to a normal number, and this guy is still stuck inside. So 6 square root of 3. So notice this and this are equal to one another, which means these are equal to one another.